Good morning, class. Happy Friday. Please make sure that you listened to the substitute and took attendance and have your notes in front of you. You do not need a calculator for today. We want to remind you that next week we have a test on Thursday. What we're going to look at today is the properties of exponential functions and how we can sketch their graph, and we're going to link that to how we can graph logarithmic functions and their inverses. So I'm going to remind you at the top of your notes, it says this: treat this package as if I'm teaching you. Read, highlight, circle, and underline. If you need to go back and pause this video, please do so. So graphs of exponential functions. Last week we looked at the graph of an exponential function. I'm going to refresh your memory and then we'll look at more. So there's always a horizontal asymptote by looking at the vertical shift up or down. So if you look at a function like f of x equals 2x, it's plus 0 here, so it's not shifted, so the horizontal asymptote's at y equals 0, which is the same as the x-axis. If you have a graph like 2 to the x minus 4, you're shifting the graph down 4, so there's a horizontal asymptote at negative 4. Similar for the plus 5, then it would be at 5. When graphing exponential functions, first always determine the horizontal asymptote, then the y-intercept by plugging in x equals 0, you know that, and then pick some second point, maybe at 1 or negative 1. Once you have the 2 points with the asymptote, you'll be able to see if it is decreasing or increasing. So here's an example, 3 to the 2x. My thinking is, where's the horizontal asymptote? And so I find that it's at y equals 2 because of the plus 2. Then I find the y-intercept by plugging in x equals 0. Remember, anything to the 0 is 1. And then I pick another point. I did x equals 1 because I know 3 to the 1 is just 3. Then I plot my 2 points along with the asymptote. So some facts. The domain is always all real numbers. The range is restricted from the horizontal asymptote. The graph will always increase, like the picture here, or decrease. And on the right, you can see that the y-intercept is just at 0 when you have the regular form. If it's shifted up or down, the y-intercept will change. Okay, so for logarithmic functions, I want you to take a moment, fill in these charts. You can pause the video here. You have the same equation as above, so if you're going to be filling in some of these values, you already know that at 0, the coordinate is 3, and at 1, the coordinate is 5. To make a table of values for the inverse, you're going to flip-flop your x and y and add that sketch to your previous page. So add that sketch to the sketch that you see on this page. If you need to pause the video, you can. So again, if we graphed both of these at the same time, you would see the exponential function, the line y equals x, and the logarithmic functions. Notice that if you have some exponential function, the inverse is going to be a log with that same base. Okay. So graphs of logarithmic functions inverse what we know about exponential functions. So now there's going to be a vertical asymptote by looking at the vertical shift up or down. Okay, so instead of a horizontal asymptote, we now have a vertical. So we're looking at what happens to the x. So when I see x minus 2, it's tricky, that's moving it to the right. So the asymptote's at x equals 2. When I see x plus 3, it's actually being shifted to the left 3. So think about what we did with completing the square. So now the asymptote's at x equals negative 3. So similar to what we did graphing before, we're going to do vertical asymptote, the y-intercept. Sometimes you don't have a y-intercept though, because you can only take logs of positive numbers. So for example, if we look at this example of log base a of x plus 3, if I somehow get a negative where the x plus 3 is, then I cannot have that. Okay, find the x-intercept, determine a second point, and then label and sketch. So asymptote, x and y-intercepts, label and sketch. Okay, so some facts. Now the range, remember we're inversing what we know about exponential functions, so the range is going to be now from negative infinity to infinity. The domain will now be restricted from a vertical asymptote instead of the horizontal one, and the graph will always increase or decrease again. Now instead of the y-intercept, we'll know the x-intercept is at 1, 0 instead of 0, 1. Okay, we're going to try some questions. So the first one, given the function, describe the transformations. So if I'm going to look at describing the transformations in graph A, I am shifting the whole graph down 2. I'm shifting the whole graph down 2. What's happening to the x here is nothing. So the asymptote here is at x equals 0. In part B, I'm shifting horizontally 2 units to the right. So then my asymptote is at x equals 2. In 3, I have a vertical stretch of 2. But my asymptote is going to be at x equals 0. So here, sketch the graph of -2 log x minus 1 without a calculator. So my thinking is, what are the transformations? I know that there's a vertical stretch of -2, and since it's negative, there's reflection over the x-axis. I know this x minus 1 tells me I'm shifting my graph to the right 1. So my vertical asymptote then is at x equals +1. So I looked at the transformations, I looked at the asymptote. Now I need to find the y-intercept by plugging in x equals 0. So when I plug in x equals 0, I get -2 log of 0 minus 1, or -2 log of -1. And you cannot take the log of a negative, so there's actually no y-intercept, which makes sense based off our vertical asymptote. It's never going to cross x equals 1. It will never reach x equals 0. Now finding the x-intercept by plugging in y equals 0 is a little bit trickier. So using some of the rules that we had before, we say 0 equals -2 log to the log of x minus 1. We're going to reverse move the power up, and then we're going to loop. We're going to say, okay, this is log base 10 to the 0 equals x minus 1 to the -2. 10 to the 0 is 1. Remember, a -2 means we're going to take the reciprocal of x minus 1, so I get 1 over x minus 1 quantity squared. I cross multiplied here, 1 times 1. I double distributed the x minus 1. Now I'm going to move the 1 over, and then I end up with x squared minus 2x equals 0, factoring, and then I get x equals 0, x equals 2. This is where we need to think, do we need to reject? And in this case, I reject at 0, because if I plug 0 back into my original, I get the log of -1, which does not exist. Okay, so we need to make another point. So what I did here was I plugged in 11, and the reason why I chose 11 is because I know that 11 minus 1 is 10, and I know the log of 10, log base 10 of 10, is just 1. So now I have another point. So I sketched these by first sketching the asymptote, my x-intercept, my third point, and then once I had those 2 points, I was able to see what direction my graph was going to move in. It was going to be decreasing. If you're done with this, you might seem, wow, that was a little bit tough, and it was. Often we will have our calculator on the IB exam for these questions, but if you don't, this is what you would do, and so try to model my thinking. Notice what the domain is because of that asymptote. It's from 1 to infinity, not inclusive, and then the range is from -infinity to infinity. So we're going to try one more together. If we have f of x equaling the ln, or natural log of 3x, for x values greater than 0, again, we can't take the natural log of a negative number, find f inverse. So we swap our x and y, so I get x equals the ln of 3y. Then I say, okay, take e of both sides. So now I get e to the x equals e to the ln. I did this because that kind of cancels out, and I get 3y. Then dividing both sides by 3, I get f inverse equals e to the x over 3. So at this point, if you need to pause or go back, you have plenty of time, and then please try the practice. That's going to be your homework. Have a nice weekend, and if you have any questions, I'll be after school on Monday.